All right, an educative day keeps unemployment away. We're doing the minimum size subarray sum, and this is the problem statement. I'm trying different things from now on, trying to get the videos as short as possible, below under 15 minutes. And in this vertical format, that's very good for looking at things on phones and removes a lot of the wasted space on the IDE and browser. I also tried cleaning up the sound a bit, so let's go. Given an array of positive integers, nums, so we have an array and it's made up entirely of positive integers. We call that array nums, and a positive integer target, a single integer target. Find the minimum length of a contiguous subarray whose sum is greater than or equal to the target. If no such subarray is found, return 0. Examples are worth, especially an example with images, worth like a billion words. So we have 4 and 3 as the answer here, because the target is 70. Sum up to 7, and they're the shortest side-by-side elements in the array that are greater than or equal to that sum. So we return 2 because there are 2 items. Here, nothing works. Nothing here sums up to 11. So we return 0. Here, 7 and 3 sum up to 10. And there are 2 items. So we return 2, and there's 2 items side by side. We return 2. We can look at this quiz and try to see if we've understood it. 7 and 2 would sum up to 9. 1 and 8 would also sum up to 9. So 2. For 12, 12, how do I get 12? 3, 4, and 5 sum up to 12. And nothing else. So 3 items. I believe 6. Just 6. 1 item. Awesomeness. Alright, so this is the quiz. I've said to show the solution because dragging and dropping doesn't really do much for me. To initialize the window size with the maximum possible value, usually infinity in JavaScript solutions. Iterate over the input array, and in each iteration add an element of the array in sum. If sum is greater than or equal to the target, compare the previous window size with the current one and store the smaller value in the window size. Slide the window to the right while subtracting the leftmost element from the window to the smaller subarray with a sum until the smaller subarray with a sum smaller than target is found. Okay. Repeat the process until the entire array is iterated. If the window size is not equal to positive infinity, return it, otherwise return 0. Yay. So let us look through the solution very quickly in our debugger. So it's noteworthy that they don't even have a naive solution for this problem, because I guess at this point it's fairly straightforward. Traverse the array using a sliding window, calculate the sum of the elements in it, compare the sum of the target value. If the sum is greater than or equal to the target value, store the size of this window. Repeat it until you find the minimum size subarray. So we have window size, positive infinity. We use the start and end variables to track left and right, okay, of the subarray respectively. Initially, we set both to 0. Slide the window over the input array. Using these 2 variables, in each iteration, we increase end and add a new element of the window to sum. If sum is greater than or equal to target, we increment start. If sum exceeds or equals to target, we compare the current subarray size with the window size. The smaller of the 2 will be stored in window size. We repeat the min. It looks something like min, open brace, sum, and window size. Repeat 3 and 4 to find the smallest subarray. If window size is positive infinity, we know that there are no subarrays. Therefore, return 0. Otherwise, we return the window size as the length of the subarray. And there's this nice diagram to walk through. Initialize sum to 0. The variables we have: window size is infinity. Cyan pointers in the first element in the array. Target is 7, so we step through it. We add the value of the current index to the sum. Check if it's greater than or equal to target. The current index is represented in yellow. The 2 is not bigger than sum. Move on. Move end. Our current subarray. Add the value of the newest element to sum, check if it's greater than or equal to 7 to 3. Now sum is 5, it's still not greater than or equal to 7. Same thing. And we'll notice start stays where it is, but end moves. Still less than target 6. Now 8 is greater, Now we have a window size that is not infinity. So we update that 4 items. Start, end minus start. So 0, 1, 2, this is 4. Window size is 4 elements long. Okay. Right. The minimum of 4 is infinity, 4 elements long. Now shrink it by moving the star index 1 step forward. Subtract the outgoing element from the sum, so subtract 2 from sum. Now we're back at 6, less than. So now we move on 10. 10 is bigger, so we do the min again, still get the same 4. Now move here. We have 7 again. How about that? But this time it's 3 elements long, so we're going to update this. 3. Awesome. Look at that. Update the window size with the minimum of the current window size and the variable window size. Now it's 3. 4 and 2 is still less than 7, so we'll move end 1 step forward. This is greater, but it's still 3. One more, but now it's less than the window size. So we get to fairly straightforward. Let's step through this solution in our debugger so we see how it works. So we are currently dealing with number 7. Minimum size subarray sum. This is our answer. JavaScript always helps, catches a lot of stuff. I can just type this real quick. A lot of times when you are just trying to use TypeScript, all you need to do is to type the arguments and you're done, really, for the most part. Let's walk through some examples in the code by putting these in our branches, the necessary branches, and running the code in our debugger. So we run this, watch a few variables. So right now we're evaluating this array and our target is 7. So just by observing it, we know 4 and 3 are the answer, and the answer is supposed to be 2. We've initialized a few variables. Start, added to watch, end, 0. The sum that we're keeping track of, our tally. Oh, I mean, we know that the target is 7. This is our array. This is the current window size. And this is our sum, our active sum. I think this is all we have to watch for now. Yes. This is everything we need to pay attention to. Everything over here. And so these aren't large, so I'm gonna just give the code more space to breathe. So we've created a loop while the end. Remember it from here, actually. End. Back to the beginning. So we're in our first iteration. Start and end start at 0. Sum is already, we've stepped through here, so sum has already been updated to 2. just like it is over here. This is the current state of our debugger. Sum is at 2. Window size is still infinite. Target is 7. Start and end are at the same place. So we go in, because the sum is not bigger than the target, we break out of this loop, basically. This loop doesn't happen. I'll leave this here actually. And then now end is going to shift. End is now 1. It's probably confusing, like hopping back and forth like that. But, I hope it's clear. The sum is updated. Now it's 5. Sum is still not bigger than target, so nothing happens. The sum gets updated one more time. 6, still not bigger than target, nothing happens. 8. Now sum is bigger than 7. It's greater than or equal to 7. So now we come in here. Current subarray size, so just subtract the end from the beginning. Plus 1. That's to get the length. It's a 4-element array. Because right now start is at 2. And end is at 2. So there are 4 elements in between those ends. So we get 4 for the current subarray size. So the window size is the minimum. And now we can remove the first element because we're shifting start. We're moving start along, just like in the diagram. And now the sum is 6. As 8, this 2 got dropped off from, wait, where's sum? Yes, 2 got dropped off. Sum was 8, and then 2 got dropped off here, this line. Now start is going to move by 1. It's now less than. I can store this variable to watch. False. Go back to the beginning. And it's going to be, what element are we considering right now? No, always know what we're considering right now. So 4 plus 6 is going to be 10, which is going to be greater than the target. So we do the same dance. First. And it just keeps going. It's a very short loop of things to do. Up, and we do that until end reaches the end of the array, in which case we've studied every single thing we need to study. Same thing, just keeps going, just like the image before. Okay, now window size is not infinity, so return window size to profit. All right, come to the end of the video. Hope you enjoyed it. Something you can look at later. Upload the code to the GitHub. Essentially, this is all you need, really. Very, very straightforward algorithm. That's that about that. Thank you for watching. Peace.